All right. So welcome back from the break. Um, so let's do a little bit of a review. Last time we did uh inverse functions. So basically, this for regular trig functions, sine inputs an angle and outputs a ratio of two sides of the triangle. And the inverse is the other way around. The inverse of sine takes the ratio and outputs the angle that corresponds to this ratio. So for the inverse sine, the output is between minus pi over 2 to pi over 2. For inverse cosine, the output is between 0 and pi. And for inverse of tangent, the output is between minus pi over 2 to pi over 2. This is because the sine and cosine and tangent are both, they are all periodical, so we only takes a portion of it to represent the other values. All right, so basically there are many angles that correspond to the same value when you input the sine, and we only take the angles in between these ranges as the output for the inverse function. So now comes to today's lecture, trig identities. So trig identities are basically a equation that involves trig functions. All right, so there are two sides of the equations. In order to verify these trig identities, we work on one side of the equation, and the goal is to get this side of the equation into the other side of the equation so that the equation is balanced. Okay. Um, So in order for us to work our way to get to the other side of the equation, there are some tools that we can use. So first of all, there's a identity that involves tangent, right? Tangent is basically sine over cosine. And there is another function, cotangent, that is cosine over sine, right? And there is a secant of function. Secant is 1 over cosine, and cosecant is 1 over sine. These are the trig identities that involves fractions. And there's another one that is Pythagorean's identities, basically says sine square plus cosine square is equal to 1. All right, how are we going to use them? For example, we have 2 times tangent times secant, and then we want to express it using only sine. Okay, so first of all, 2 times tangent theta secant theta. All right. So first of all, we convert tangent as sine over cosine. All right. So we want to get to using sines and cosines only. So it's sine theta over cosine theta. All right. So for secant, we use this identity 1 over cosine. So secant of theta is actually 1 over cosine of theta. Wait, 1 second. All right. And now we combine these terms. The numerator is 2 sine. and the denominator is cosine square. However, it's not done here because cosine square theta can be converted to sine using Pythagoras theorem, right? Since sine square plus cosine square is equal to 1, then cosine square is basically 1 minus sine square. All right. And now we only have signs in our expression for 2 times tangent times secant. And we're done here. All right. Any questions? Okay. So for the following trig identities, okay, so the first one, tangent times cosine equal to sine. So we want to convert the left-hand side into sine, okay? So the trick here is to convert everything in terms of sine and cosine and simplify as much as we can. So tangent is basically sine over cosine. No. Cosine of x. And now we cancel out the cosine because they are in both sides of diffraction. This is left hand side. And after canceling, you only end up with sine of x, which is what we want, the right hand side. So for the next one, we have cosecant times cotangent. Cosecant times cosine times tangent equals to 1. So I'll go here to convert everything on the left into 1. Basically, the hint here is everything can be canceled out. So let's convert everything in terms of sine and cosine like we did in the first one. Cosecant, if you remember, is 1 over sine. And cosine, we just leave it like that. And tangent is sine over cosine. Okay, and now we look at the terms. There is one sine on the top and one sine on the bottom, and we can cancel each other out. And there is one cosine on top and one cosine on the bottom, and we can cancel them out as well. So basically we end up with 1 over top and 1 on the bottom. So basically 1 over 1, which is 1. And we're done. Next one, we have cotangent divided by cosecant equals to cosine. So again, we work on the left-hand side and we want to get to cosine. So we convert everything in terms of sine and cosine. So cotangent is cosine over sine. divided by cosecant. Cosecant, if you remember, is 1 over sine. Okay. And division is basically multiplied by its reciprocal. So if you flip 1 over sine, it becomes sine. So it becomes cosine over sine multiplied by sine. And now there's one sine on the top and one sine on the bottom. They can be canceled out, and we only have cosine left, which is exactly the right-hand side. Okay. And for the next one, it's a bit complicated. You have a lot of terms. Okay. So when you look at the left-hand side, you have two terms in the parentheses. So we work on each one first. So for the first one, 1 minus cosine square using Pythagoras theorem is sine square. Okay. And 1 plus cotangent of x, we can rewrite cotangent into cosine over sine. So basically 1 plus cosine square over sine square. Okay. Now we can just multiply sine square into each term in the parentheses. Okay, sine square plus times 1 is sine square. By the way, this is left-hand side. We only work on the left-hand side now. And sine x square times this fraction, the sine square can be canceled out, and we only left with cosine square. And sine square plus cosine square using Pythagoras identity is basically 1, which is the right-hand side. For the last one, you have this fraction is equal to the other fraction. Again, we only work on one side of the equation. So we work here. So when you look at the right-hand side, is not as simple as the terms we have before. So we want to identify the key characteristic or key feature here. The key here is there is a 1 minus sine theta on the numerator. So we want to have that in our goal. So what do we do here is we multiply 1 minus sine on both sides of the fraction and see what happens. Okay. So for the denominator, 1 minus sine times 1 plus sine, using the difference of square formula, is basically 1 square, which is 1, minus sine square, and we can keep whatever happened on the numerator as it is. We don't have to simplify this yet. Okay. And when you look at the denominator, 1 minus sine square, using the Pythagoras theorem, is basically cosine square. Okay, and finally, there is 1 power of cosine theta on both sides of the fraction. We can cancel 1 power of each other. So this is gone, and the square can be reduced to first power of cosine. And we only have 1 minus sign left in the numerator. And this is what we have on the right-hand side. So we are done here. Any questions so far? So far, so good? Okay. So next, we move on to the next topic is sums and differences, identities for sines of x and cosine of x, okay? So in this case, we have more tools that we can use in terms of trig identities. Okay. So for the sum identities, basically, if we add the angle inside of cosine and add the angle inside of sine, you can rewrite it as using the angles of each of the sum using sine and cosine. Okay, same thing as differences. If you have difference of 2 angles, it can be represented as cosine and sines of each angle respectively. Okay, the key here is to memorize the pattern. Okay, for cosine, when you have addition, the result here is subtraction. So this 2 is opposite. But for the sine, when you have addition, you also have addition here. So the sign here is the same. The other one is for sum of cosine, the result is 2 of the cosine times together and 2 of the sine times together. So these 2 are the same functions. But for sine, when you have the sum identities, you have 2 different trig functions multiplied together, and then the other 2 different trig identity functions multiplied together. Okay, same thing as difference. When you have cosine, you have cosine times together plus sine times together. But for sine, you have sine multiplied by cosine and cosine multiplied by sine. Okay. So for example, for cosine of 7 pi over 12, so the key here is to write 7 pi over 12 into 4 pi over 12 plus 3 pi over 12. 4 pi over 12 basically is pi over 3. 3 pi over 12 is basically pi over 4. And we have sine and cosine for these 2 angles respectively, okay? So, oops. So now we have cosine of pi over 3 plus pi over 4. So using our sum identities is cosine of pi over 3. I remember for cosine is two of the same functions multiplied by together. So it's cosine of pi over 3 times cosine of pi over 4. And the other one is sine of pi over 3 times sine of pi over 4. And for cosine, the sum identities and the difference identities, the sign here is opposite to the sign here. So this is minus. Okay. So cosine of pi over 3 is 1/2, and cosine of pi over 4 is square root of 2 over 2. Okay. Minus sine of pi over 3 is radical 3 over 2, and sine of pi over 4 is square root of 2 over 2. And you can simplify this as 4 of square root of 2 minus square root of 6. Okay. So for the next one, you have cosine inverse of radical 2 over 2 plus sine inverse of radical 3 over 2. So the hint here is to work on the inverse functions first. Okay, so cosine inverse of radical 2 over 2. Right. You can use your table, your calculator, or your unit circle to find the cosine inverse of radical 2 over 2, which is pi over 4. And sine inverse of square root of 3 over 2 is basically pi over 3. All right, so this becomes cosine of pi over 4 plus pi over 3. And we just did it here. Okay. Any questions? So for the next one, you have, we want to find sine of alpha minus beta, right? So we know that we can use the difference identities for the sign here. So sine of alpha minus beta is sine of alpha times cosine minus cosine of alpha times sine of beta. So if sine alpha is 4 and cosine beta is 1, and both alpha and beta are in the first quadrant, that means alpha and beta are both angles for a right triangle. So for example, this is the triangle that involves alpha, right? If sine of alpha is 4, that means the sine of alpha is basically the opposite over oops, sorry, this is 4 over 5. This is a typo. And this is 1 over 2. Sorry. So if sine of alpha is 4 over 5, basically the opposite is 4. The hypotenuse is 5, right? And then using Pythagoras theorem, a squared plus b squared is equal to c squared. So you can get the third side of the triangle as 3. Okay. So you can do the same thing for beta. Okay. If the cosine beta is 1 over 2, that means the adjacent is 1 and the hypotenuse is 2. Again, using the Pythagorean's theorem, you can get the third side as radical of 3. Right. So this 2 is from Pythagorean theorem. Okay. And now we have 3 sides of the triangle. Then we can find out what is the sine of alpha and what is the cosine of alpha. So sine of alpha is 4 over 5. And cosine of alpha is 3 over 5. And for beta, the sine beta is square root of 3 over 2. And the cosine beta is 1/2. Now we have sine alpha, cosine beta, cosine alpha, and sine beta here. All of them are here. So just plug in all these 4 values into here. Right, so sine alpha is 4 over 5. Multiply by cosine of beta, which is 1/2. Right. Minus cosine of alpha, which is 3 over 5 here, times sine of beta, which is radical 3 over 2. Okay, then we can simplify this as 10 of 4 minus 3 square root of 3. Any questions? Okay. Now we move on. Since we have sums and difference identities for sine and cosine, then we can have it for tangent as well. Remember, tangent is basically sine over cosine. Okay, and then we use the sum and difference identities for sine and cosine. We can end up expanding the terms for both sides of the fraction. Okay, and then from here, if we divide it by cosine of alpha times cosine of beta on both sides of the fraction, okay, then we end up with 4 fractions here. So each 4 terms becomes a fraction that is over cosine alpha times cosine of beta. So for this fraction, sine alpha cosine beta divided by cosine alpha times cosine beta, the cosine beta is cancelled, so we only end up with sine alpha over cosine alpha. For the first fraction here. For the next fraction, we have cosine alpha sine beta divided by cosine alpha cosine beta. So cosine alpha is cancelled. We only have sine beta over cosine beta. Divided by, for this fraction, cosine alpha cosine beta divided by itself becomes 1 minus sine alpha sine beta divided by cosine alpha cosine beta becomes sine alpha divided by cosine alpha times sine beta times cosine beta. Okay. And we can simplify each term. Sine over cosine is tangent, so tangent alpha. This one is sine tangent beta. One minus sine over cosine, again tangent alpha. And sine beta over cosine beta is tangent beta, which is what we have here. Okay. Right. And you can work the same way to get the difference identities for the tangent as well. Basically, just apply this difference identities for sine and cosine, and then divide it by cosine alpha and cosine beta on both sides of the fraction. Okay. So the next one is the cofunction identities, right? For sine, you can rewrite this as cosine traded off by expressing the angle as pi over 2 minus this angle. Same thing for the cosine is basically rewrite the angle as pi over 2 minus this angle, right? The reason why we can do that is when you look at the right triangle, right? If this is theta, then the other angle is pi over 2 minus theta, because pi over 2 is 90 degrees, right? And when you have the sine of this theta, is the adjacent over hypotenuse, so it's the side A over side C. But when you look at the cosine of the other angle here, the A becomes the adjacent. So A over C becomes the cosine of this angle. And the same thing for cosine. Cosine of the theta is B over C, but B is the adjacent for the other angle. So B over C is actually the sine for the other angle. So for example, if you have sine of pi over 7, you can rewrite it as cosine of pi over 2 minus pi over 7, which is cosine of 5 pi over 14. Okay. Any questions? Okay, so that's the end of the class. All right, so now is the time for any administrative issues or something about homework, the class, or anything.